Global greetings to all my friends. Today I am back with an interesting topic which is fun with magnets, which is chapter 4 from my science book. Let's start. Ajay bought a game. In the box, there were several small pieces in the shape of sphere, cylinder, and cuboid. Some pieces were in the shape of an arc too. He took them out. Some of the pieces were tightly sticking to each other. He pulled them apart, but he had to apply energy. On the other hand, some pieces were trying to move away from each other. This made him wonder, what do you think the pieces of Ajay's new game were? Yes, they were magnets. You must have seen stickers that remain stuck on iron surfaces like almirahs or refrigerators. Similarly, there are pin holders and dusters which stick on the white boards without falling. These things stick because of the presence of magnets in them on the or their surfaces they are attached to. So, you see, magnets can attract certain materials towards themselves. What will you do if accidentally the box of pins falls on the floor? Will you pick them up one by one or will you use a magnet? Let us explore and learn more about magnets in this chapter. Discovery of magnet. Magnets are believed to have been discovered accidentally by a shepherd boy named Magnus, who lived in the town of Magnesia in ancient Greece. One day, the iron sole of a wooden stick he was carrying to control his sheep got stuck to a rock. He was unable to pull it away. It was discovered that the rock was made of natural magnetic material. This rock was called magnetite, probably after the name of the boy. Magnets are of two types, natural magnets and artificial magnets. A magnet is an object or a material that has the unique property to attract iron and some other metals. Natural magnets. Magnetite or magnetic rocks are those magnets which form naturally. Natural magnets contain iron. Some rocks, minerals, and meteorites are all natural magnets. The Earth, the Sun, the stars, and most of the planets are also naturally magnetic. Some insects, birds, and fish also have extremely small quantities of magnetically sensitive material inside their bodies. Artificial magnets. After the discovery of naturally occurring magnetic material, artificial magnets were developed in different shapes. For example, bar magnets, horseshoe magnets, cylindrical magnets, bar-ended magnets, ball-ended magnets, etc. The most commonly used form are the bar magnets and the horseshoe magnets, U-shaped magnets. Artificial magnets are more efficient and stronger than natural magnets. Magnetic and non-magnetic materials. Based on whether or not materials are attracted by a magnet, they can be classified as magnetic and non-magnetic materials. Materials that get attracted towards magnets are called magnetic materials. For example, iron, nickel, cobalt, etc. Materials that are not attracted towards magnets are non-magnetic materials. For example, plastic, paper, zinc, etc. Aluminium, wood, rubber, stone, gold, and silver are some other non-magnetic substances. If you roll a magnet in sand or soil, some small particles will stick to it. These small particles are tiny iron particles present in sand or soil. You observe that more fillings cluster at the two ends of the magnet. From this, you get to know that the magnetic strength of a magnet is not uniformly distributed throughout its surface. It is maximum at the ends, which are also called its poles. If you suspend a magnet in air, it will arrange itself in such a way that one end points to north direction and the other to the south direction. The end of a magnet pointing towards the north is called north-seeking end or north pole, while the other end is called south-seeking end or south pole. Due to this same property, magnets were used by navigators. For the same reason, magnetic rods were also called lodestone. It was perhaps an ancient Greek scientist Archimedes who used lodestone to take out nails from an enemy ship, which resulted in sinking of the ship. Directive property of a magnet. Let's perform the activity given below. Directive property of a magnet. Suspend a thin bar magnet horizontally so that it can rotate freely. Wait till the magnet comes to the rest. It will arrange itself in a north-south direction. Rotate the suspended magnet and you will find that it again comes to rest in north-south direction. A freely suspended magnet always points in north-south direction due to its directive property. When a magnet is suspended freely, it always rests in north-south direction. This direction-seeking behavior of a magnet is known as its directive property. This happens because the Earth behaves like a big bar magnet such that its magnetic south pole rests in the geographic north and magnetic north pole rests in geographic south. Hence, the north pole of a magnet rests in the north direction as you will learn later in the chapter that opposite poles of magnets attract each other. Magnetic compass. Travelers have been using the directive property of a magnet to find directions for centuries. The progress in the method of finding directions led to the invention of a device called magnetic compass. A magnetic compass is a small box with a glass cover. It, it has a magnetic needle in the center which can rotate freely. The dial of the compass has directions marked on it. The magnetic needle also has its end marked as north and south. Finding directions using a compass. Place the compass at the point where you wish to find directions. The compass needle indicates north-south direction when it comes to rest. Rotate the compass till the north and south marks on the dial are at two ends of the needle. Now the direction to and from a particular place can be found. We will make our own compass, but first let us learn how to make a magnet. The geographic north pole and magnetic north pole of the earth are not in the same place. Indians, several years ago, used a device similar to the modern day compass. It was called Machyantra, fish machine. It was a wet compass which consists of a fish shaped magnet floating in a bowl filled with oil. Making magnets. We can use a magnet to magnetize a piece of iron as, as turn and turn it into a magnet. This can be achieved by a method known as single touch method. This method is explained in activity 5. Place a strip of iron on a table. Touch one end, say north pole of the bar to the piece of iron and move it from one end to the other firmly. After you reach the other end of the strip, lift the bar magnet and repeat the process. Repeat this for 30 to 35 times. Bring some iron fillings near the magnetized piece of iron. You will see that the iron fillings attach to the piece of iron. Hence, an iron strip has been magnetized. Notice that the end of an iron strip brought in contact with the north pole and of magnet first will become north pole of the new magnet. The other end becomes the south pole. However, if the end of the iron string is first stuck with the south pole of the magnet, it will also become the south pole. Magnetism induced by single touch method is not very strong, hence it is not used in anymore. It is not in use anymore. Nowadays, magnets are made with electric current. Make your own compass. Take a needle and bar magnet. Now, make this needle into a magnet as you learned in the previous activity with the help of the bar magnet. Take some water in a flat bottom bowl. Take a small piece of aluminium foil. Stick the needle in the foil by piercing it gently. Place the foil in the bowl of water. You will observe that the needle will make the foil rotate till it comes to rest in the north-south direction. Some more properties of a magnet. Like poles repel, unlike poles attract. Whenever two magnets are brought close to each other, there is some interaction between them. For better understanding, let's perform the activity. Attraction and repulsion in magnets. Take two bar magnets and one piece of iron bar. Suspend one bar of magnet as shown. It will come to rest in north-south direction. Bring the like poles of two magnets closer. That is, bring the south pole of the other bar magnet closer to the south pole of the suspended bar magnet. What do you observe? Can you say that like poles repel each other? Now, bring the unlike poles of two magnets closer. That is, bring the north pole of the other bar magnet closer to the south pole of the suspended bar magnet, or vice versa. What do you observe? Can you say that unlike poles repel each other? Repeat the activities using the bar magnet. What do you observe? Can you say that a magnetic material is always attracted to a magnet? Thus, you can say that like poles of a magnet repel each other and unlike poles attract each other. You also know that a magnetic materials are attracted to a magnet regardless of the pole. So, how can you identify whether a given object is a magnet or a magnetic material? It is through the property of repulsion. Therefore, repulsion is a short test of a magnet. Poles exist in pairs. The two poles of a magnet, that is, north and south poles, always exist together. It means that a magnet cannot have a single pole. The two poles cannot be separated by any means. So, we see that no matter how many times we divide a magnet, it will always have a north pole and south pole. Hence, two poles of a magnet cannot be isolated as they exist in pairs. Magnetic strength is maximum at its poles. You have already learned in one of the previous sections that the magnetic strength is strongest at the poles of a magnet. It is equally strong at both the poles. Attractive property of a magnet. A magnet has a property to attract some substances like iron, cobalt, and nickel when brought near it. This property is known as attractive property of a magnet. Magnetic effect to non-magnetic materials. You can conclude that the magnetic effect of a magnet can be felt even through the non-magnetic materials. Uses of magnets. Magnets are used in toys, door catchers, bulletin boards, stickers, paper clip holders, pencil boxes, etc. Magnets are used to sort out magnetic substances from scrap at junkyards. Audio and video tapes, cassettes, computer drives, etc. can store data because of magnetism. Magnets are also used in telephones, doorbells, speakers, etc. Magnets are used in electric motors and generators. MRI scan is a very useful tool in the medical industry. It is done with the help of magnets. Demagnetization and storing of magnets. Magnets lose their magnetic properties if not handled properly. This is called demagnetization. The various reasons due to which magnet can lose its magnetic properties are heating a magnet to high temperature, hammering a magnet, Dropping a magnet from height repeatedly and keeping a magnet close to magnetic media like cassettes, mobiles, televisions, compact discs, and computers, a magnet is weakened by these devices. How to store permanent magnet? Self-demagnetization is the process by which magnets tend to become weaker after some time if their poles are left free. To retain their magnetic properties, permanent bar magnets are stored between soft iron pieces called magnetic keepers. A magnetic keeper consists of a wooden piece with two magnets on its two sides, and wooden with the unlike poles on the same side, magnets are always stored in pairs and kept in opposite positions. However, one piece of soft iron is sufficient to store a horseshoe magnets. Let's revise the chapter with a small summary. The property of a magnet to attract materials towards itself is called its attractive property. There are two types of magnets: natural magnets and artificial magnets. Materials that are attracted towards magnets are called magnetic materials. These are mainly iron, nickel, and cobalt. Materials which are not attracted towards magnet are non-magnetic materials such as wood, plastic, rubber, etc. Let's discuss the new terms of this chapter. Magnet. A substance that possesses the property of attracting iron object is called magnet. Lodestone. It is a type of magnetic rock found in nature. Attractive property. The property of a magnet to attract objects toward itself is known as its attractive property. Directive property. It is the property of a magnet by which it arranges itself in north-south direction when suspended freely. Compass. An instrument containing a magnetized needle which helps in finding direction is known as magnetic compass. Magnetic keepers. They are soft iron pieces used to store bar magnets. So, this is the end of chapter 4, Fun with Magnets. Stay tuned, stay positive. Till then, bye. मम्मा मम्मा बंद कर दो